and in this tutorial we're going to be going over our insert at method. Now what the insert at method does is it inserts a node at a certain position. So here we just have our linked list. We have our header pointing to the first node, tail pointing to the last node, and size is equal to 4 because there are 4 nodes within our linked list. Now these numbers in here represent the position. So this is position 1, 2, 3, or 4. Or you could consider them as indices. So from here, let's take a look at case 1. So case 1 is to check to see whether or not we're inserting at a valid position. So if the position is less than 1, we're not going to insert it into our linked list. And the reason being is that we're going to start at position 1. Now the second criteria for case 1 is whether or not the position is going to be greater than size plus 1. So why is it size plus 1 and not size is equal to 4? Well, size plus 1 is just position 5. And I could easily achieve that by calling the append method, which adds to the back of the list. So if I try to insert at position 6, we're going to call that an invalid position. So now let's take a look at case 2, which I pretty much gave away, is what happens if the user wants to insert at the end of our list. Well, all we need to do is compare the size plus 1. So if the size plus 1, in this case, that would give us 5. If the user passes in the position of 5, all we're going to do is call in the append method. Alright, so from here, let's go on to case 3. What happens if the user wants to insert at the front of our list? Well, we already know how to solve this problem. So if the position is equal to 1, all we're going to do is call our prepend method. And again, we're using our prepend method and our append method because they take care of our header and tail pointers for us. So they'll automatically update what header is pointing to and what the tail is pointing to. So now let's move on to case 4. So now let's say instead of adding to the front of the list or the back of the list, let's say I want to add to position 2 or 3. So for this example, I'm going to choose position 3. So the very first step is we need to create a node that we want to insert within our list. So now that we have the node that we want to insert, we're going to have to get the pointer from the previous node, right? So this node, position 2, is going to have to point to n. And then n is going to have to point to position 3 to preserve the linked list. So in order to do that, we're going to have to traverse the list. So by traversing the list, we're going to need help. So we're going to need 2 pointers. We're going to need a pointer to the previous node, and we're going to need a pointer to the current node. Now current is going to be initialized to point to whatever header is pointing to, which is going to be the first node. And since there are no previous nodes yet, we're just going to declare our previous pointer. So now we need to traverse the list, and we're going to execute a loop in order to do that. So the first step, prev is going to be pointing to what current is pointing to. Then we're going to have to advance what current is pointing to the next node within the list. Then the loop executes again. Prev is going to be pointing to what current is pointing to. And then current is going to be pointing to the next node within the list. Now this is where we stopped. Why? Because we want to insert at position 3. So from here, let's think of this logically. We want to insert n at position 3. And who has a pointer to position 3? Well, prev has a pointer to the node that has a pointer to position 3. So what I want to do is have prev's node point to n. And I could do that by saying prev arrow next is going to point to n. But now that we did that, look what happened to our linked list. Our linked list is broken now because we have position 1, 2, and then n, which is the new position 3. But now we lost these 2 nodes. So now n has to find a way to point to the previous position 3. Well, who has a pointer to the previous position 3? Current has a pointer to that node. So now I could just say n arrow next is going to be pointing to current. So you can see from here that we successfully inserted n at position 3 and we maintained our linked list. So now all that's left to do is actually increment the size since we inserted a new node. So now let's go ahead and take a look at this in code. Alright, so from here you can see we have our insert at method. It's returning nothing, so it's void. And we have our two parameters here. The first parameter in position is going to be the position where we want to insert our newly created node. And int data is the data that we're going to use to call the one argument constructor for our node class. Alright, so now let's move on to case 1. Check if it's a valid position being passed in. So in order to do that, I'm just going to say if the position is greater than size plus 1. And remember, it's size plus 1 and not size, because size plus 1 can easily be achieved by using the append method. So if the position is greater than size plus 1, it's invalid. Or if the position is less than 1, it's also invalid. And it's invalid because position 1 is going to be our starting point position. So all we're going to do is just going to return. Alright, so now let's move on to case 2. Check if the insertion is at the beginning of the list. So that's pretty simple. So I'm just going to come down here, else if position is equal to 1, which means I want to insert at the beginning of the list. Then all I'm going to do is call the prepend method. Alright, so from here, let's move on to case 3. Check if the insertion is at the end of the list. Well, that's pretty simplistic, so I could just come down here and say else if the position is equal to size plus 1. And the reason why it's size plus 1 and not size is because let's say I have 4 nodes. If the position is equal to 5, that means I could easily achieve this by just calling the append method. And that will insert that node into position 5. So now let's move on to the last case, all other cases. Now I could use an else statement here, but just to triple check everything, I'm going to say else if the header does not equal to null. Now the first step here is obviously to create the node that we want to insert within our linked list. Now the second step, remember we need 2 pointers, a pointer to the previous node and a pointer to the current node. And we're going to use these pointers when we traverse through our linked list. And if you see here, you can see that prev does not get initialized to anything. It's just declared. And that's because we have no previous nodes to point to yet. And current is going to point to whatever header is pointing to. So now let's write the loop. So I'm just going to come down here. I'm going to say for int I is equal to 1 because that's our starting point. While I is less than the position, I'm just going to say I++. Now first, we need to save what current is pointing to. So prev is going to be pointing to what current is pointing to. And then current is going to advance to the next node. Now from here, it's going to kick us out of the loop, and prev is going to be pointing to the previous node, and current is going to be pointing to the current node. So now I could just come down here, and I could say prev arrow next is going to be pointing to n, and n being the node that we want to insert, but now n needs to point to what current is pointing to. And the last step, all we need to do is increment the size. So I'm going to go down to our main method. And let's actually test this out. So I am just going to remove the remove at. And I'm going to say list.insert at. And let's insert at position 2. And we're going to insert the value of 10, for example. So now I'm just going to save this. Let's bring up the terminal. I'm going to change to my desktop. Let's compile it. And now let's execute it. And you can see that 10 gets inserted at position 2. So I'm not going to test the position at position 1 or the last position, because those just use the prepend and append method. So that pretty much wraps it up for the insert at method.